Dear students of Standard 10, welcome to your math class. This is Mohammad Sharkar. Now I am going to take my second class on chapter 8, exercise 8.3. In first class, I have solved up to question 5. Now I am going to solve questions 6 and 7. Question 6 is, if the vertical angles of two triangles standing on equal bases are supplementary, prove that their circumcircles are also equal. Look at the question. If the vertical angles of two triangles standing on equal bases are equals of the triangle, and vertical angles are supplementary, prove that the circumcircles are equal. Here are the two triangles ABC and DEF with equal base, BC equal to F, and some of the vertical angles, vertical angles A and D. We know vertical angles are the angles which is opposite to the base is called vertical angles of the triangle. Here, if BC is equal to base, then vertical angle is its opposite angles. BC EF equal to base, then vertical angle is its opposite angle. Now it is required to prove that the circumcircles of these two triangles are equal. So particular enunciation is, let ABC and DEF be two triangles where BC equal to EF and angle A plus angle D equal to 180 degree. Why? Because they are vertical angles and given vertical angles are supplementary. It is required to prove that the circumcircle of these two triangles are equal. Now, to prove this question, we have to construct the figure. First, we have to know what is circumcenter is. What circumcenter is? Circumcenter is the intersecting points of the perpendicular bisector of the sides. Here, perpendicular bisectors, red line represents the perpendicular bisectors of AB, and this red line represents perpendicular bisectors of BC. Those perpendicular bisectors are intersecting at a point O. So O is the circumcenter of this triangle. Similar, P is the circumcenter of this triangle. O is the center. Now radius will be, if you join OB, then we get the radius. OC radius. If we take O as a center and OB as a radius and draw a circle, then we get this circle. If we take P as a center and P as a radius and draw a circle, then we get this circle. Let the angle BOC equal to alpha and angle reflex BOC equal to beta. Let angle reflex EPF equal to X and angle EPF equal to Y. Construction. Draw two perpendicular on AB and BC. AB and BC red lines represents the two perpendiculars which intersects at O. Here these two red lines represent perpendiculars which intersects at point P. Then we get the center of the circumcircle. Now join OB, OC, PE, PF. We get the radius of the circles, and taking O as a center and OB as a radius, we draw this circle. Taking P as a center and P as a radius, we draw this circle. Then we get these two circles. It is required to prove that these two circles are equal. In the circle ABC, you can see that angle BAC, that means angle A, angle BOC, that means angle alpha. Here angle A is inscribed angle and alpha is circular angle. We know circular angle is twice the inscribed angle, so twice A equal to alpha, where standing on same arc, BC. Similar case, standing on same arc EF, inscribed angle is D and central angle is angle X. So twice D equal to angle X. Adding these two, we get alpha plus X equal to, taking 2 as a common, and we get angle A plus angle D. And angle A and angle D are supplemented to each other. That's why sum of these two angles is equal to 180 degree and to 180 360. Now you get alpha plus X equal to 360 degree from adding these two. But we can see that X and Y is total complete angle. Complete angle is 360 degree, and so sum of these two angles, angle X plus angle Y, equal to 360 degree. If we mark this equation as 2 and previous is 1, at comparing 1 and 2, we get here x plus alpha equal to 360, here x plus y equal to 360. So obviously alpha equal to y. Comparing these two, we get alpha equal to y. Alpha equal to y. Now in the figure we can see that triangle OBC is isosceles triangle because OB and OC radius, and PEF also isosceles triangle because PE and PF have radius. And angle alpha equal to angle y, therefore remaining angle is obviously equal. These two angles are equal, therefore remaining angles are equal, and also these two are equal. So four angles, all angles are equal. These two triangles are equiangular. So all angles are equal, and given BC equal to EF. So another condition, BC equal to EF. All angles are equal. This equal to this, and this equal to this, and BC equal to EF. So these two triangles are congruent by SS theorem, angle side angle theorem. You can say that from angle side angle, these two triangles are congruent. So OB equal to PF. So we can write OB equal to PF. Since OB and PF are radius of the circle, this circle and this circle, so this radius are equal. So obviously these two circles are equal. Hence proved. Clear? Now question 7. Prove that the bisector of any angles of a cyclic quadrilateral, the nature of the quadrilateral is cyclic, and the exterior bisector of its opposite angles meet on the circumference of the circle. Here let an angle A and bisector of angle A equal to this, and opposite angle of A is C. So exterior angles of opposite angle of A is this. Angle A, opposite angle is C, and exterior angle of this angle is equal to this. The bisector of any angle of a cyclic quadrilateral, and the exterior bisector of its opposite angles, and exterior bisector of its opposite angle, this angle, and exterior bisector of its opposite angle, this intersect at point, say F. It is required to prove that F is on the circle. That means if we prove angle BAF plus angle BCF equal to 180 degree, and angle B this to 180 degree and this to 180 degree, then opposite angle are supplementary. Therefore the quadrilateral is cyclic quadrilateral. For this, if ABCD are cyclic quadrilateral, therefore ABCD cyclic quadrilateral, therefore BAD plus BCD, angle BAD plus angle BCD equal to supplementary angles BAD plus BCD, supplementary 180 degree, and this is cyclic quadrilateral, so exterior angle is opposite interior angles. Exterior angle is equal to exterior angle is equal to opposite interior angles. It is a theorem. Exterior angle, if ABCD is a cyclic quadrilateral, then exterior angle is equal to opposite interior angles. So these two angles are equal. And AF is the bisector of this angle, and CF is the bisector of this angle. So obviously this angle equal to this angle FAD equal to DCF. FAD equal to DCF, because these two angles are equal, and AF is the bisector of this angle and CF is the bisector of this angle. So these two angles are also equal. Now BF, that means this angle plus this angle, BF plus BCF. BF plus BCF, we can separate BCF into BCD plus DCF, BCD plus DCF, BCD plus DCF, but DCF is equal to FAD. DCF and FAD are equal, therefore we can place FAD in the place of DCF, and BAF and FAD. If we add BAF and FAD, then we get angle BAD. Then we get angle BAD. So angle BAD is BAD BAF plus FAD equal to angle BAD. This is BCD. BAD plus BCD equal to BAD plus BCD equal to 180 degree. So we get angle BAF plus angle BCF. That means BAF and BCF equal to 180 degree. Therefore these two angles are supplementary. Obviously these two also supplementary, because sum of four angles of the quadrilateral is 360. Opposite angles are supplementary, so this quadrilateral is cyclic quadrilateral. Hence F is on the circle. Clear now? I hope it is clear now. Do this in your CW copy and submit it within 2 days. Till then, thank you. Allah Hafiz.